We'll start the recording. So here we go. So these are the solutions to the Unit 5 test. Before I launch that, I'm going to create a solutions whiteboard. It's the work we're going to almost certainly have to do at some point. All right. So here we go. So Cora has the following 14 cards in a deck. 3 green, 4 blue, 7 red. She draws a card from the deck of 14 playing cards. Then she puts the card back in the deck, shuffles again, and draws another card. What's the probability that both are blue? Because she is replacing them and shuffling, it's the same probability each time. We've got 4 out of 14 the first time and 4 out of 14 the second. That reduces to 2 out of 7. So 4 out of 14 and 4 out of 14, so we multiply. And 4 out of 14 reduces to 2 out of 7. 2 times 2 is 4. And 7 times 7 is 49, as we've already seen dropped in the chat. So I still will be going through every question step by step on this one. So any questions about number 1? All right, number 2. Calgary ranks top place in Canada for the proportion of daylight hours when the sun is shining, or when the sun shines. The probability that the sun shines bright on any given day is approximately 0.52. In a non-leap year, the average days that a Calgarian sees no sunshine in a typical day to the nearest whole number is. So the probability that the sun shines is 0.52. So the probability that the sun doesn't shine is 1 minus 0.52, which is 0.48. And 365 times 0.48 will give us the number of days that corresponds to, or 175, because that works out to 175.2. So to the nearest whole number, that's 175. Any questions about this one? So a certain jelly bean package contains 18 black, 20 red, 28 yellow, 18 green, 16 orange, and 22 purple. If one jelly bean is randomly selected, then the probability to the nearest hundredth that it is a green or purple is. So we have 18 green and 22 purple. I'm going to use a very long vinculum here. 18 green, 22 purple. And then we have 18, 20, and 28. And 18, 16, and 22. So our numerator is 40. Our denominator is 122. We're asked for the nearest hundredth. So we just divide that out, our 0.32786885525, etc. To the nearest hundredth is 0.33. So any questions about this one? Right, we are adding the two because it's an OR problem. Now, use the following information to answer the next question. Which of the odds for and probability statements are equivalent? Now remember, with odds, it's not favorable cases compared to all, it's favorable compared to unfavorable. So 1 to 2 is 1 over 1 plus 2, or 1 over 3. So it's not row 1. 3 to 2 is 3 over 3 plus 2, which is 3 over 5. So it is row 2. And this is 4 plus 6, which is 10. So 4 over 10 reduces to 2 over 5. So rows 2 and 3 are equivalent. Any questions about that one? All right, so number 3. 2 cards are drawn, or which statements describe a dependent event? So one where the second event is impacted by the first. 2 cards are drawn without being replaced. From a standard deck of 52, the first event is drawing a 5 and the second is drawing a queen. But still, the probability of pulling a queen varies because now there's only 51 cards in the deck. So the fact that we pulled a 5 meant pulling a queen the second time a little bit more likely. So statement 1 is dependent. Statement 2 is not, because the marbles are drawn with replacement. So you take it out, you put it back, and then you take it out again. Because there's replacement, there's no change. Tossing 2 nickels, the probability of getting 2 heads, these are independent events as well. And a 3-color spinner and a die, also independent. Okay. Yeah, good morning, Gerline. All right. So, okay, so we are almost halfway through going through yesterday's test. So here, there is a 0.60 probability that Paul will be going fishing tomorrow. The odds against Paul going fishing is. So odds against. So we know the odds and probability is 0.6. So the probability of not going fishing is 0.4, which we can write as the fraction 2 over 5. But then for odds, it's 2 compared to 5 minus 2, which is 2 to 3, as we are now seeing in the chat. So 2 to 3 are the odds against Paul going fishing. Okay. Any questions about number 4? Okay. So number 5, there are 20 cards numbered 1 to 20 in a box. One card is selected and its value is recorded. The card is then replaced and another card is then drawn. Determine the probability of drawing an even number and then drawing a number that is a multiple of 4. So keep in mind that they are replaced. So first, we have to draw an even number with all the cards from 1 to 20. So that's 10 out of 20 or 1 out of 2. That's the probability of our first step. And we need to draw a number that's a multiple of 4 in our second step. There are 5 multiples of 4 in there. 4, 8, 12, 16, 20. Easy way to do that is just 20 divided by 4. So we have 5 multiples, which is 1 over 4. 1 over 2 times 1 over 4 is 1 over 8. And 1 over 8 is 12.5%. Any questions about this one? All right. So here we go. The probability and odds of falling down while snowboarding for 3 students is listed below. And we need to arrange these from the lowest probability to the highest. But we've got different pieces of information. So Bennett. Okay. So the odds in favor of falling down is 14 to 11. So the probability of falling down for Bennett is 14 over 11 plus 14, which is 14 over 25, or 0.56. And I believe the name of the next person was Carter. The odds against falling down while snowboarding is 8 to 17. So if that's odds against, the odds in favor are the reverse, 17 to 8. So it's 17 over 8 plus 17, which is 17 out of 25, or 17 times 4 gives us 0.68. And then David, thankfully they just gave us outright probability of falling down to 0.61. There's no extra work we have to do there. So the lowest is Bennett, then David, then Carter. So that is C. So are there any questions about this one? So we mostly need some careful reading to see that we have the odds against in there as well. All right. So number 3. Tala has 6 identical red marbles and 9 identical blue marbles in a paper bag. She pulls out one marble at random and then another marble without replacing the first. To the nearest hundredth, what's the probability that she pulls out a red and a red? So it's 6 red and 9 that are not red. So the first time she pulls a marble, the probability is 6 out of 15 that it's red. Now she doesn't replace it. So the second time, right, the first marble is red and the second marble is red. There's only 15 red marbles left out of 14 total marbles. So we can reduce that to a 1 out of 3. We can reduce these to a 2. And it becomes 1 out of 7, which they requested to the nearest hundredth. So it's 0.14. Although technically, because they were asking for the nearest hundredth, we could have done this without the reductions. We could have done 13 over 210 and gotten exactly the same answer. So it is 0.14. Any questions on this one? Alrighty. Okay, glad to hear that. Okay, so number 7, 3 experiments and related events. And we want to find which ones are mutually exclusive. So remember, mutually exclusive means you cannot have both outcomes simultaneously. It's one or the other. So number 1, rolling a fair die and getting a 2 and a 6, that die is only going to be a 2 or a 6. It cannot be both. So 1 is mutually exclusive. So that eliminates option C. Number 2, randomly selecting a number from 1 to 10 inclusive, event X is selecting odd, event Y is prime. Well, 3, 5, and 7 are both odd and prime. So those events are not mutually exclusive. So it must include 1 and cannot include 2. Therefore, because it's multiple choice, this dictates that 3 must be mutually exclusive. I'll still discuss why, because this thing might also show up in, say, a numeric response, and you just have to enter the digits for everything that's mutually exclusive, 1, 2, 3, and there's no guide for how many digits. So or it could be written response. So number 3, randomly choose one marble from a bag, and if you're only choosing one, it is either red or green. That's why they're mutually exclusive. So, anyone have any questions about this one? Okay. Here we go. The probability that Sam goes to the Oil Kings game on Saturday is 0.4. The probability that he goes to the Edmonton FC game is 0.7. The probability that he does neither is 0.2. We need to find the probability that he goes to both. So this is one where we are going to need to set up our two-way frequency tables. So we'll put the Oil Kings and no Oil Kings and the Edmonton FC and no FC. Alrighty. So now we know the probability that he does neither is 0.2. So that goes in here. We also know the probability that he goes to the Oil Kings game is 0.4. So that means this entire column adds up to 0.4. This entire column has to add up to 1 minus 0.4, or 0.6. We know that there is a 0.7 probability that he goes to the Edmonton FC game. So this entire row adds up to 0.7. This entire row adds up to 0.3. So now if these two numbers add up to 0.6 and that's a 0.2, this has to be a 0.4. If these two numbers add up to 0.3 and that's a 0.2, this is a 0.1. Now adding it vertically or horizontally, either these two numbers that add up to 0.7, these two numbers that add up to 0.4, or even saying the whole board adds up to 1, this has to be a 0.3. So that's the probability he goes to both. It is 0.3. Does anyone have any questions about the numeric response 4 here? All right. There you go. A television game shows that the odds in favor of winning the grand prize is 2 to 7. To the nearest hundredth, the probability of winning the grand prize is... Well, again, these are odds in favor, but because they're odds, it's 2 over 2 plus 7, which is 2 over 9, which is 0.2 repeating. So then we just put in the right number of 2's they requested to the nearest hundredth. Any questions about this one? All right, so we submit, and there we go. So that's what we were shooting for. All right. So as usual, I will make these available to you. I think not just the practice tests, I'll make the unit tests available for unlimited practice between now and the final, which still hasn't been scheduled yet. So, but we know it'll be coming up in June. So you guys can go through and practice with these questions and have a chance to figure out the way you do it and to refresh yourselves. All right, so that wraps up the solutions to the test. I will now stop the recording.